Hello everyone. Today we are diving into memoization, a powerful optimization technique that can supercharge your JavaScript applications. By the end of this video, you'll understand what memoization is, why it is useful, and how to implement it in your code. So let's get started. So what is exactly memoization? In simple terms, memoization is an optimization technique that involves caching the results of expensive function calls and returning the cached result when the same input occurs again. Imagine you have a function that takes long time to compute, like calculating the nth Fibonacci number. Without memoization, every time you call the function with the same input, it will perform the entire computation again. Memoization solves this by storing the result the first time you compute it, so you can quickly return the result on the subsequent calls with the same input. Memoization is particularly useful when you have a function that is called frequently with the same inputs, or the function is computationally expensive, or you want to improve performance by reducing the redundant calculations. By avoiding repeated calculations, memoization can significantly reduce the time complexity of certain functions, making your applications run faster and more efficiently. Let us see how to implement memoization in JavaScript with a simple example. We'll use a Fibonacci sequence calculator, which is the classic case where memoization can dramatically improve performance. This function works, but it is highly inefficient. For large values of n, it recalculates the same Fibonacci number multiple times. Now let's optimize this using memoization. Here what's happening, we create a memoized Fibonacci function that initializes a cache object. The inner fib function checks if the result of a given n is already in the cache. If it is, it returns the cached value. If it is not, it will calculate the result, store it in and then store it in the cache, and then return it. This approach reduces the number of calculations and significantly speeds up the function. Memoization is not a silver bullet and shouldn't be applied everywhere. It's best used when the function is pure, that is, the output only depends on the input, or the function is computationally expensive, or the function is called multiple times with the same arguments. Avoid using memoization if your function relies on external factors like user input, random values, or time dependent results, as these won't be benefiting from caching. And that's memoization in a nutshell. It is simple yet powerful technique to optimize your code and improve performance, especially for functions that are called repeatedly with the same inputs. If you found this video helpful, please give it a thumbs up and subscribe for more coding tips and tutorials.